So here's a look at another glancing collision problem. Now we did one already in these videos, but here's a second one where things are moving. They're not moving perpendicular to each other in the beginning, but let's say that we have a 1 kg block that is moving towards a 2 kg block that is initially at rest. Now after the collision, what's observed is that the 2 kg block moves at a speed of 5 meters per second at an angle of 30 degrees, and our goal is to find the speed of the 1 kg block and the angle theta that it makes with the horizontal. Okay, so this is the top view of the picture, and once again, nothing's been mentioned about whether the collision is elastic or not. So clearly we cannot use KEI equals KEF. But what we have at our disposal is PI equals PF. And what we'll do is, since it's a glancing collision, we'll conserve it along the X direction and along the Y direction. So we'll do PIX equals PFX. So we'll do it along the X direction first, and then we'll do the same for the Y. Now in the beginning, if you'll notice, 1 kg block is the only one moving, and it's moving simply to the X direction only. So its momentum along the X is simply equal to 1 times 10. Okay, the second one has 0 momentum. Now right after the collision, the 1 kg block is moving with a speed of V at an angle of theta. So along the X direction, by using vector components, we know that the is simply equal to cosine of theta. Plus, for the 2 kg block, the velocity is very simple. The momentum is very simple. It is equal to 2 times 5 multiplied by cosine of 30. Great. So let's simplify this. We got 10 is equal to V cosine of theta plus 10 cosine 30. 10 times cosine 30 is 8.66, and this tells us that V cosine of theta is equal to 10 minus 8.66, which is equal to 1.34. Okay, let's not put any units here right now. Alright, great. So we have this. Let's repeat the process along the Y direction. Okay, so we repeat the process for the Y, and what we end up getting is PIY equals PFY, and in the beginning along the Y direction there are no momentum components, so it is all 0, and in the end we know that the momentum is going to be 1 times V times sine of theta plus 2 times 5 times sine of 30. Actually it's going to be minus, because we see that it's going along the negative Y axis. Okay, great. So we have our second equation, which gives V sine theta is equal to 2 times 5 is 10, sine of 30 is 0.5 is equal to 5. So now we have two equations. This is equation 1 and this is equation 2, and we can solve them very easily. Now what I like to do is I like to divide one by the other. That eliminates the V sine theta over V cosine theta is equal to 5 divided by 1.34, and this implies that tangent of theta is equal to, what is it, 3.73, and this gives me theta is about equal to, theta equals tangent inverse of 3.73, which is equal to 75 degrees. Now that we know theta, we can plug for theta into any of the equations and find V is equal to 5 divided by sine of 75, and this gives us 5.17 meters per second. So this gives us our two values. Now to show you a quick way of also doing it, if you have two equations, so you have V sine theta, just another way of obtaining V or whatever. We know V sine theta is 5, and then we know V cosine theta is equal to 1.34. We can use a trig identity here, okay, which is basically that sine squared theta plus cosine squared theta equals 1. This is something that some of you may already know. Some of you are going to find out very soon. It's a very simple identity to prove. In fact, go ahead, prove it for a right angle triangle. Just draw a triangle, and if this is the angle theta, this is A, this is B, this is C. Show that when you do sine squared theta plus cosine squared theta, you end up getting 1. It's a very simple, straightforward proof. Anyway, we'll use this identity, and what we'll do is we'll square each of these sides. Okay, so we'll have V squared sine squared theta, and then we'll add V squared cosine squared theta to it, and we'll square their respective right hand side. So 5 squared plus 1.34 squared. Okay, and when you do this, what you get is you get V squared times sine squared theta plus cosine squared theta, and this is equal to So this is approximately equal to 26.79, and you see all this ends up being 1, so we get v square is equal to 26.79, and this implies v equals 26 square root of 26.79, which happens to be about 5.17 meters per second. So it's just another way of doing it, and once you get v, you can go ahead and find theta. Okay, something to keep in mind. So this is just an alternate way of just solving these two equations. Alright, so that's for this glancing collision problem.